Hello, today we are going to talk about C++ array initialization in the context of developing for KDE. So C++ arrays, you can declare them using where is the syntax? So this is an array of fixed size 4, so index is 0 through 3. Let's go with a simpler type. Let's go with int. Okay. And if we declare like this the C++ array, then no initialization will take place. So the four values, the array has 4 slots, and in those 4 slots the values will be not initialized, will be random, could be 0, could be 30, could be 3 million. And what we're talking about is how do we make sure that all of the values inside this array are always 0. That's what we mean by initializing an array. This is an array which is not initialized. Let's see how this thing looks like. For instance, in Qt Creator, let's go with File New Project, Plain C++ application, choose, let's create a new directory. And let's name this thing .1xm. Does not exist, so what? Okay, next. Okay, so build system cmake, next. The default kit, which is the desktop, I'm on Kubuntu 22.04, so the GCC that's installed from Kubuntu packages, dip packages. Next. No version control, next. Okay, so we did cmake. We can run this thing. It says hello world. We can debug this thing. We don't really need the tree view with the project. Okay. F10, 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 F5. Okay, so let's initialize. Let's just define an C++ array, but not initialize it. Like this. Let's build. This says unused variable cars. Okay, can we run this thing? Yes, we can run it. Okay, so now let's list the values inside of the array. Let's say values, cars of 0, cars of 1. Okay, Control S. So it says uninitialized variable cars. Okay, let's see if this thing builds. So it's just what? So we need an and in here. Okay, so this is not a GCC build error, not a GCC build warning. This is probably from the Qt Creator IDE from clangd. So both a warning, not assigned a value, and uninitialized variable from CPP check. This thing is from where? From CPP check. This thing. Okay, let's disable CPP check. Close. Restart now. Okay, so if you look at the output, it says values, some 1 billion and 32,000. So the values in this array are totally random, hopefully. Let's run it again to see. Yes, there's some differences between different runs on what values are inside of the array by default. Let's see the CMake build configuration. So it's debug. Does this make a difference if we go with release with debug information? Build and run. So rel with debug info puts zeros. Okay. Whereas debug, let's build, puts a negative value. Yeah, so debug puts debug CMake build configuration. The values in the array are random, but if I build with release with dep info, then I get zeros. Still, we can't depend on the fact that certain build configuration might put zeros in this array. So let's see what are the rules and how to initialize a C++ array. Okay. So we can initialize C++ arrays by giving all of the values. So let's do that. So this would be A. Let's go with B. So the syntax is equals, curly brackets, and then values. So 4, 3, 2, and 1. So on index 0, index 1, index 2, index 3. So for all of the positions inside of the array, all of the 4 we have given values, semicolon, build, and run. So it says 4 and 3. So that's correct. So that's declare but not initialize. Then there's initialize all elements in the array. What happens if we have more values in the right hand side than in the left hand side? Control S, we go build, and it says too many initializers for int4. So in function int main error too many initializers for int4, the 100 value is extra. Okay, so this is a C++ error. Let's see how is this thing defined in here. So we go C++ language. Where are you? CPP reference, C++ language initialization, and the rules are complex. There's how do we read this? So there's a value initialization, which is what we want. There's a direct initialization, there's copy initialization, there's list initialization, there's aggregate initialization, and there's reference initialization. All non-local variables with static storage are initialized. All non-local with thread local storage are initialized as part of the thread launch. Constant initialization, non-local static, thread local variables are 0 initialized. Constant initialization probably takes place at compile time. BSS segment of the program manage, or the program image. So that was for statics. And then for the other things, which is called dynamic initialization, non-local variables. Static data members, variable templates that aren't explicitly specialized. All inline variables that are not partial, implicitly or explicitly initialized. All other non-local variables within a single translation unit. early dynamic initialization, deferred dynamic initialization. Okay, let's dig deeper. So we have default initialization with the object or new t. So we want to look not at initializing structs or classes or objects. We want to look at specifically C++ arrays. Okay, let's look at value initialization. So value initialization has syntax parentheses. Since C++11 a pair of curly brackets. There's also new and then a pair of curly brackets. And the curly bracket syntax is since C++11. Okay, so now the question becomes what version of C++ standard do the Git repositories from the KDE community use? So let's look at that thing. So for that we have many KDE Git repositories, so from invent.kde.org on my tilde/kd/src directory because I've built them with kdsrc build. Okay, so we have utilities, we have libraries, we have frameworks. What else? Education, games, so a ton of modules. Okay, how do these modules set the preferred version of the C++ standard? Let's look at the framework, for instance. Which one? Okay, internationalization. We're searching here for not for 11. Nothing interesting. Okay. Let's search for 17. Okay, so it sets C++ standard C++ 17 and with GCC G++ compiler. So somewhere it sets that it prefers the standard to be C++ 17. So let's search for C++ 17. This file is the So this C++17 is from compile underscore commands.json, which is a file which is a new thing. It's generated by kdsrc-build for integrating with newer IDEs with Visual Studio Code and clang-d. And it contains the commands that are run during the make phase. So when we build modules with kdsrc-build, we do three things. Well, the first is similar to the GNU autotools configure step, which is the cmake step that creates a new directory which is called build. So it's tilde/kd/build/education/blinken, not tilde/kd/src/education/blinken. And then make files are generated in that build directory. And then the steps the second step is run to compile everything. And then make install is run to install the files into tilde/kd/usr. So whatever the make step does is written to the compile commands JSON file. So it says C++, a ton of include directories, and then the standard C++17, and then the name of the translation unit, so a CPP file, and the output file, which is a .o file. Okay, so at least Education Blinken, Frameworks Attica, Frameworks Baloo, Frameworks BlueZQt, Breeze Icons, Framework Integration, Key Activities Stats, Key Archive, KEUTH, and many more use the C++ standard C++17. What about the other modules? Is there a Git repo from the KD community which uses a C++ standard which is older than C++17? Let's git include again, and we'll look for CXX. Why do we look for that? Because in this sample application, which we created inside Qt Creator, the files are cmake lists and main.cpp. Let's look at file system view, and the cmake lists txt says cmake CXX standard 17, so I can see that the standard is 17 inside of the cmake lists txt file. So let's search for CXX and see if there's any cmake lists.txt files which contain this line. So we need uppercase CXX, and we search case sensitively. So we have flags. We'll need to include just the cmake lists file. cmake lists.txt file. So there's education cantor, which says standard C++11. There's calcium, which says C++17. There's compound viewer, which says C++14. K-Hangman, C++ 17, K-Stars, C++ 17, LabPlot, C++ 11, Education. What about frameworks? So I can see that the three standard versions are 11, 14, and 17. Is there something lower than 11? So there's one framework, ECM, which says that it wants C++ 14, and ECM is the basis of everything. If ECM does not build, then no KDE module will build. So the fact that it requires more than C++ 11, which is C++ 14, is really important. Then what do we do for the rest of the modules from the frameworks? They don't seem to say what standard version do they want. Okay, so the C++ standard version that we use is important because we need to build, we need to include C++ libraries, dependencies, non-KDE, non-Qt, such as Exiv 2. Okay, C++ standard 11 in Kirigami. Yeah, 11 in K9speed. This is outside of the frameworks. /search for CMake C++ CXX standard. And look everywhere. So it's 11, 17. And then there's this comment which says that if the variable CMake CXX standard is already defined, then none of this will be applied. And this works like this. So it says there's the following CMake C++ standard default variables. If KDE compiler settings level greater than or equal 5.85, then C++ standard is set to C++ 17. Otherwise, it's set to C++ 11. Okay, let's see if somebody defines this. So inside of frameworks, no, these things are not defined in frameworks. Okay, so from this comment, I can see that there's modules which define KDE compiler settings level to less than 5.85, such as QQC2 breeze style, which goes with 5.84, so that's less than 5.85. So that will use C++11. And then there's partition manager, which uses 5.85, which will go with C++ standard 17. KTP accounts KCM, KP plugins, LSCAP, KIGO, KReversi. Okay, so let's guess that most of the Git repositories from the KDE community use C++, the standard C++11 or newer. Okay, so let's change in our sample application the C++ version to 11. Control S. Okay, let's CMake again. Okay, let's compile again. The same error, too many initializers for array. Okay, back to the documentation. Okay, so this is the value documentation. There's no equal sign in here. Direct initialization. No equal signs. Copy initialization with objects. We read aggregate initialization because an array is an aggregate. So an aggregate is one of the following types. Array type. So the array is an aggregate, so it can use aggregate initialization. In our case, there's a type, which is int, where are you? And the size 4, and then the identifier, and then goes equals. We're not going to use the dot, which is designated initializers, aggregate class only. So we're not using that. We're using 1 or 2, which are these two, which are initializing an aggregate with an ordinary initializer list. Okay, so this does not work. Okay, so we saw this thing here. We really need to put exactly the number of elements in the right hand side as in the left hand side. If we put more, we get an error. What if we put less? Let's log all of the elements. Control X, Control V, V, and V. So handle 1 and 2 and 3. Okay, so what do we do? Control S, build. So it says that we need to, so we have 4 positions in the array and we're initializing with just 3 values. Control S, build, no build issues. We can run it. And it says 4, 3, 2, and then 0. So we can guess that on the first position, on position 0, it put a 4. On position 1, it put a 3. And on position 2, it put a 2. And on the rest of the positions, it puts zeros. So where does it say such a thing? So we're at 1. So aggregate initialization says reject the following ill-formed cases. The number of initializer clauses in an initializer list exceeds the number of elements of the aggregate. So this thing is not allowed. So in here it has 4 positions and it on the right hand side it has 5. So that will not work. Says the number of initializer clauses in the initializer list exceeds the number of elements of the aggregate. Or initialize an array of unknown bound with an empty initializer list. We didn't talk at all about arrays of unknown size yet. So we'll need to look at those two. So in here it's called an unknown bound. Okay, and then we have arrays with new. So these are probably dynamic arrays. Okay. So in this situation we have less items in initializer list than elements of array. Okay. Puts zeros on the rest of the positions in the array. Okay. So we're not in any of these situations. We're with a situation that on position 3 it doesn't know what to put. So it says determine the explicitly initialized elements of the aggregate as follows. Since C++20 this is not the case, designated initializer list, that's this with a dot character. We're not using the dot character. So let's skip over this part with the C++20. Otherwise, if the initializer list is not empty, the explicitly initialized elements of the aggregate are the first n elements of the aggregate, where n is the number of elements in the initializer list. So n in this case is 3. The first 3 elements in the aggregate, which is the first 3 elements in the array of 4 elements, explicitly initialized. Explicitly initialized 3 elements of the array. Okay. So this is the explicit part. If the otherwise the initializer list must be empty and there are no explicitly initialized elements. So we also have this situation where we don't put anything in the right hand side, just a pair of open and closed curly brackets. So that's an empty initializer list, and then there will be no explicitly initialized elements. The program is ill-formed if the aggregate is an union, no unions. Okay, and the third step, initialize each element of the aggregate in the element order. Initialize each element of the aggregate of the array in the element order. So it will initialize the third element first, the fourth, the one with index 3. All value computations and side effects associated with a given element, we don't do anything, computations or side effects, are sequenced before those of any element that follows it. Okay, not that. For each explicitly initialized element, if the element is an anonymous union, no. The element is copy initialized from the corresponding initializer clause in the initializer list. So copy initialized. If the initializer clause is an expression, no expressions. If the initializer list is a nested brace list, braced init list, no recursion, no subaggregate, no nested. Non-union aggregate, yes. Each element that is not explicitly initialized is initialized as follows. So we did the explicit ones, 4, 3, and 2. And now we have an not explicit one, which is the last one in the array. If the element has a default member initializer, so member means non-arrays. So structs and classes, no such thing. Otherwise, if the element is not a reference, it's the int type, the element is copy initialized from an empty initializer list. I'm guessing this is the case. Initialized. if the element is not a reference, no. It is copy initialized from an empty initializer list. It's not ill-formed because it compiles. If the aggregate is in union, not. No union, brace elision. The braces around the nested initializer list may be omitted. We don't do nested initializer lists. Designated initializers, that's with the dot syntax like this, dot x, not our case. Character arrays. So char, signed char, unsigned char, char 8t, char 16t, char 32t, wchar t can be initialized from ordinary string literals, UTF-8 string literals, UTF-16 string literals, UTF-32 string literals, white string literals, optionally enclosed in braces. So it's not our case, we're using ints, not chars, so we don't have to deal with strings. An array of char or unsigned may be initialized by an UTF-8. No. No characters, no string literal. Okay, next. An aggregate class or array may include non-aggregate public bases members elements which are initialized as described. Okay. Narrowing conversions were permitted. We don't do any conversion. All of the values are indeed integers and the type is integer. Until C++, aggregate initialization could only be used in variable definition. Aggregate initialization could only be used in variable definition and could not be used in a constructor initializer list, a new expression or temporary object creation. Until C++ aggregate initialization on variable definition, not constructor initializer list, not new expression, or temporary object creation due to syntax restrictions. Yes, that's important. The initialization of C array structs is different from the C++ syntax for initialization. So the empty initializer list is only since C23, so it's from the future. So you need to be really careful when you do such a thing, when you use an empty initializer list, because that will not work in C. So if you have, for instance, a H file, an header file, an include file, that must be used both from C++ and C. You can't use these syntaxes, so an empty initializer list, in that header file. So this is valid C++ since at least C++11, but it's a valid C initialization just from C23. Okay. An object is empty initialized if it is explicitly initialized from initializer empty. Okay, so the rules for C++ initialization are different from the rules of C initialization. Okay. So array initialization, we're not using string in C, in the C programming language, not C++. Not using this, not using string literal. We're using this scenario where we have less in the initializer list elements than in the array. So this is syntax 2, since what's this with var args? Okay, so comma separated list of constant expressions that are initializers for array elements. Arrays of known size and unknown size may be initialized. All array elements that are not initialized explicitly are empty initialized. So let's write somewhere down the rules for C, not C++, array initialization are different because of different versions of the C and C++ standards. Okay, so for C we might go with this thing. Just put one value in the initializer list that makes it valid since forever. So it works in all versions of C, both since C99 and until C99. And it says okay. So actually it looks like it's a good idea to initialize C++ arrays with curly bracket, zero curly bracket, because then you will not have to think really hard. Is this a CPP file or an H file? Is this the C programming language or the C++ programming language? Which version of C programming language? Because this works in all versions of C programming language, and I'm guessing it works at least on C++ language version 11 and newer. But we'll see about that. So it says, let's paste some things in here. Arrays of known and unknown size may be initialized. All array elements that are not initialized explicitly are empty initialized. Really important, because that's what we want. Whatever is empty initialization in the C programming language so empty initialization, an object is empty initialized if it's explicitly initialized from initializer pair of curly brackets, just since the newest version of the C standard, so not a case for us. In some cases, an object is empty initialized if it's not initialized explicitly, that is, pointers no. Objects of integral types are initialized to unsigned 0, yes. Objects of floating types are initialized to positive 0, important. All elements of arrays, all members of structs, and the first members of unions are empty initialized recursively, plus padding bits are initialized to 0. So this note with PSS is probably not for us. Okay. No static or thread local, just empty initialization. No implicit initialization, because that's for storage, automatic storage duration. That is. Static and threads local, okay. Explicit initialization. If an initializer list is provided, in our case, for array types, with the syntax equals, that's the only way to do it. So equals, there's no possibility of not putting the equal sign in the C programming language. Okay. Let's go back to the C++ initialization and look at the value initial, what? So list initialization is with no equals sign. Let's go back to the aggregate initialization. So an aggregate is an array type. Elements of the aggregate for array types is array elements in increasing subscript order. Okay. Explicitly initialized elements. The initializer list must be empty. There are no explicit initialized elements. Let's see what that looks like. Anonymous unions. Azure list is an expression. Implicit no. No nested. Non-union aggregate. No member initializer. Copy initialized from an empty initializer list. No unions, no designated, no character arrays. So this is with the exact same, no, this is with no bound specified. This is with less elements. This is with the error too many elements. Okay, so let's see this thing. Ctrl S, build, run. So it has 0 on all positions. So it's no, it has an initializer list. It's empty. There are no explicitly initialized elements. The element is not a reference, it's int. Element is copy initialized from an empty initializer list, which in this case it's all zeros for ints and 0 for floats. Okay, so we did that. What else? This guy. So this is an array of unknown bound. Okay. So what it does is that the initializer list is of size 3. The array doesn't have a size. Okay. Let's compile. And let's run. So it's 1, 2, 3 as we expected, but then we're dereferencing a stupid thing, which is out of the bounds of the array. Ctrl S, build, and run. So values 1, 2, 3. So the initializer list is used in order to compute the size of the array. So it's actually declared as an int of 3, not an int of any size, of unknown size. Let's see what the debugger thinks of this thing. F10, cars, no such value. So we can't inspect cars because it's an array. We need to inspect each individual item. Okay, let's stop the debugging. Okay, and the last thing is with the dynamic arrays. Not really, not the last one. There's also these with no equal sign, which are the same thing. So it's either 1 or 2. So it's either with equal sign or not with equal sign. So we can have and no equal sign in here and no spaces. Okay, let's see what this does. Control S and uncomment this thing. Control S, build, and run. So it's 4, 3, 2, 1. Okay, so 4, 3, 2, 1. It works the same whether it's with equal sign or not. We could use this syntax or this syntax. This syntax is only since C++11. Let's mark this thing. Okay. Then we have the C syntax, and we have its associated version without an equal. Control S, build, and build fails with the exact same error. Too many initializers for list for int of 4. Okay. What else? D. No equal sign. Control S, build, run. 4320. The exact same thing. It's just a new addition to the C++11 standard when this is allowed. So not putting the equal sign is a syntax relaxation, right? Which is possible since C++11. Okay. What about the C programming language? This probably still requires an equals sign for the C++, for the C language standards that we need inside of the KDE community. Okay, what with this thing? Control S, build, and run. So all zeros. Okay. Control S, build, and run. What about this syntax? Without equal sign. Let's put a false. Okay, Control S. Build, works, runs. Control S. And we're at dynamic arrays. Okay, let's name this 0. Dynamic arrays. Where do we see an example of a new? So it says new and then type and then initializer. What is this? Yeah, so this is we. Control C. This is EFG. Int pointer. Cars. New int. And then the initializer list must be placed on after the type definition. There's no possibility of having a second equal in here like this. Okay, so this is the only possibility. You go new, the name of the array type, and then the initializer list. So we're with okay, let's see how this works. And for Control S, Control V, Control S, potential what? Potential leak of memory by cars. Yes, that's totally true. C++, allocate new array. So we have new of int, and then the size is going to be computed out of the initializer list, I'm guessing, to before. And then we need to delete the pointer. We're not deallocating a dynamic array. Or are we? Let's see. Control C, Control V, Control S, build, and run. So 1, 2, 3, 4. Doesn't complain about leaking memory. What if we remove this thing? Control S. Says memory allocated with new and square parentheses must be deallocated with delete square parentheses, not delete. C-lang analyzer. did it apply to a pointer that was allocated in new square parentheses? Okay. So let's put this in the sample. Okay. Okay, but then what we really want to do is to edit already existing code that goes like, that's like new int of 4, and then it does some mem set or zero memory or mem copy or something to write all zeros all on of the positions of the array. So that's a problem because you need to know the size of the array in bytes when you go with the mem set. The same with zero memory. So let's look at mem set. So it does complicated things like how many, so the size in the base type of the array, then times size of the, in our case int, because it's an array of type int. We need to compute the size of int in order to decide how many bytes are inside of an int, and then we multiply that by the number of elements in the array to compute the contiguous size of the array and have that zero out, which is, these computations are messy, smell like bugs. There's plenty of places for bugs to hide inside of this computation, and it's totally not needed in many places where we can use initializer lists or empty initialization. And it's a violation of the don't repeat yourself principle. Don't repeat yourself principle. So it's about the fact that you have specified the size of the array in two places. Once where you allocate it, like in here, 4, and then a second time where you do mem set, you need to put that 4 again and then times the size of int. So this 4 is going to be duplicated. You will want to extract it as a const int, but then you can't do that because probably the syntax will not allow you, so you'll have to create a define, and then defines are macros and are not the best thing ever in C++. And it's still not needed to go with memset if you're in the situations where you don't use a dynamic array, or when you use a dynamic array which is allocated with new, so you already know the size of the array, and you just want to initialize it to not have random values. Like this. So I go Control S, build, and it doesn't give any compiler warning or error, which is strange. And we're still with many zeros because on release with debug information. Let's go with debug, build, run, still zeros. I'm not really sure why it repopulates, why it initializes the values inside of the array with zeros. Okay. So here we're talking about zeroing out arrays, not structs, as in this case. CTX thing is what? It's a struct. So we're not talking about structs, we're talking about arrays. We want to allocate them when we create them. How do we do it? In the most C++ idiomatic way, in a way that works for all of the Git repos from the KDE community, so using a really old version of the C++ standard, and not doing memset, memcpi or something else, not violating the don't repeat yourself principle, not using defines to define a macro for the size of the array. Okay, so let's do it as idiomatic as possible and eliminate many of the possible bugs and duplications. And we're not talking about putting other values than 0 in there. If you want to put 128 instead of 0, then initializer lists will not be what we want to use. For an array of 200 elements, we will not do a initializer list of 128 elements with a value 128. Just so a huge initializer list with all of the values identical, just to not do memset, because then memset is going to have less bugs than the huge initializer list, because you still have the don't repeat yourself violation, because you need to configure the size of the array inside with the size of the initializer list. If one element is missing from the initializer list, then instead of, for instance, on the last position of the array, instead of having 128, you will have 0, which is certainly a bug. And it's not going to be when we receive the array. It's going to be when we create the array. Like in here. So it says char medium of size 0, and then immediately memset medium 0 and size 1. And that's pretending that the size of char is 1 byte, because it doesn't do size 1 times size of char. And still, why do memset? Because memset is slower than using the compiler to do it. It's a don't repeat yourself violation in here. Whenever you change the size of the array medium, you will also have to edit the next lines, so the memset in here. So in here it goes new char of n, so the n size is not a const, but a const. Again, pretending that the size of char is 1 byte. Or in here it goes char buffer, and then it doesn't do an initializer list, it does a memset instead. If the second parameter of memset is 0, then it tries to it zeroes out the rest, but then maybe it zeroes out the rest because buffer was not 0 at the beginning, at the start, when it was created. It tries two things in the buffer, okay. Zero is a nice default for most header fields. What is the buffer? New char of size buffer. And it goes then 46. It's not, it doesn't put the buffer size in here, it puts a magic 46. Max path length plus 1. Why would you want to duplicate the entire arithmetic max path length plus 1? Don't repeat yourself violation. This is a struct, not an array. Okay. So the H thing is what do I want to use in here? What about this? You don't need to put the size, but we need to do it because we want this to always be 0. So we actually do is this. We either put just 1 0 in here or we put nothing in here. So when we do dynamic arrays, we know the size of the array, and we know that we don't want random values on the array, we want zeros. We don't want to do mem set 0 copy mem cpi etc. to 0 initialize the array. Okay, so with 0 works. Without 0, with an empty initializer list, it also works. So it says that there's also the possibility with round parentheses. Radio controls. Okay, and run. Okay, the round parentheses is since forever. I don't know if it initializes or not. So 2. When an object with dynamic storage duration is created by a new expression with an initializer consisting of an empty pair of parentheses, then value initialization is performed. The effects of value initialization are: if T is a class, if T is an array type, each element of the array is value initialized. So empty pair of braces does aggregate initialization, not a value initialization. Empty pair or of braces. That 26. In all cases, we can see it works in the debugger, but we don't really know what the standard says. Why it works, why it puts zeros on all of the elements of the array. And how does it do it? Does it copy construct? What does it do? We did not look at the generated assembler. We might look at the generated clang++ LLVM IR intermediate representation to see what generated LLVM IR is for all of these scenarios. That's the next thing to do. So it doesn't have a constructor taking initializer list. If T is an array type, yes. Value initialized. So we know how aggregate initialization works. A form of list initialization. And we're doing list initialization with new with this thing. Or with this thing in here, or with this thing in here, or this guy. Can we also put parentheses in here? Must be an initializer list. 11, so what's 11? Functional cast expression or another construction or other construction invocations where brace list is used to place in place of a constructor argument. Okay, so that sounds like classes and functional. Okay. Direct initialization. Any elements without an initializer are value initialized. Okay, how does value initialization work? If T is a class, no. If T is an array type, each element is value initialized. What is value initialization? It's recursive, right? Okay, so it says the effects of value initialization are: if T is an array type, each element of the array is value initialized. Each element is of type int, so then otherwise the object is zero initialized because it's not a class type and not an array type int. Okay, so the object is zero initialized. What is zero initialization? So in our case it's just int. How do we zero initialize a value of type int? So it says static, no, no, no. If T is of scalar type, yes. The object is initialized to the value obtained by explicitly converting the integer literal 0 to T. Not a reference, not an array, not a union. Is no non-union class, no. Int p, 0 initialized to null pointer value. How do we initialize a1? In. Okay, so 0 initialized to 0, so ints, when you want to 0 initialize them, it does 0 initialized to 0, so it converts 0 to the type int and is still 0. Where are you? So the effects of 0 initialization is if it's a scalar type, and it is, int is a scalar type, it converts the integer literal 0 to type integer, to type int, and it's still 0, and then initialize to the value of 0. So it goes, in this case, goes int n equals 0, so 0 initialized to 0, and then copy initialized to arg c. Okay. So we went a bit down the rabbit hole of the C and C++ standards for how do we put zeros on all of the positions of an array at the moment that we declare the array. The array could be either declared like this, when we know the size of the array, or the size of the array is still not dynamic, and the size of the array is not specified but computed from the initializer list, or the arrays are dynamic, allocated with new, and then we have the options of using a pair of curly brackets, a pair of round brackets, round parentheses, and a pair of curly brackets with a 0 inside. So it will put 0 on the first position, and on the rest of the positions, so this is explicitly putting a 0 on position 0. On the rest of the positions it puts zeros, because it does some type of not explicit initialization. So either aggregate initialization, or zero initialization, or value initialization, or list initialization, or constructor initialization, or new expression initialization, all of these will be zeros, because the base type for this int array is int. So this is it. The continuation of this is to actually look at the LLVM intermediate representation for all of these A through K possibilities. So there's an intermediate representation for LLVM, LLVM IR. This separates front ends from backends. You can have one backend for x86, 64, and then front ends for many programming languages in the LLVM infrastructure framework. Okay, so we could not use the GCC compiler, but the LLVM compiler CLang++ to compile this sample application, and not generate x86 64 machine code, but generate LLVM IR. So this was it. Thank you.